Well, so today, inshallah, we will start a new algorithm, which is also a population-based algorithm. It is some kind of genetic algorithm in that direction, but little bit different from genetic algorithm. And as we mentioned earlier, all these techniques, they are different in terms of the operations that you implementing to generate offspring from the parents. Some of them use mutation, some of them use only crossover, some of them use different operators to generate the children out of the parents. As we will see in today's algorithm, which is evolutionary programming, and later we will see also for the swarm-based techniques and also physics-based techniques. So before starting, I would like to give you some kind of brief tutorial about how to use the genetic algorithm in MATLAB. As per your request, some of you, they request just brief tutorial. Definitely you can enjoy it, and you can go and train yourself. You can entertain it. So what we will do here, very simple example and how to use it, how to use MATLAB to solve the genetic algorithm problem. And I think it is just a plug and play. It is not previously previous semesters I usually asked the students to develop a code for genetic algorithm and the other techniques also. The idea behind this, you can develop, you can access the code. If you have any idea, new idea or innovative idea, you can implement it. If you can come up with hybrid technique, you can implement it if you develop the code by yourself. But let us due to the time and this environment, and usually the communication or face-to-face, I can check the codes for the students and we can debug it. But now the situation is a little bit different, and I will ask you to use the toolbox of MATLAB to do it. So for example, if we need to I don't know whether I can write here. This is not possible. If we can okay, and let me ask you, if we have a very simple function, y equal to x minus 3 square, and we need to minimize this function, what do you think the minimum value or the optimal solution? Any solution? Any answer?
Doctor, sorry, what is the function again?
Y equal to x minus 3 square.
Three, Doctor. 3.
and minimum is 3. Yes, and the optimal value or the objective function at that time equal to what? Equal to 0. This is the objective. This is the function. So the solution, the optimal solution 3, and the objective function corresponding to this is 0. So let us see how to implement it using the genetic algorithm. Actually, are you seeing the cursor here, a mouse?
Yes, Doctor.
Are you seeing the mouse? Okay. So let us start a new script here, and we define the function. So we can write here a function, and we need to name this function. We need a unique name in order to not to interfere with the built-in function on MATLAB itself. So let us take, for example, I think Abido is not there in MATLAB. Definitely. Let us say y. Here y is the function equal to Abido of x, for example. Y is the output and x is the input. And the function is defined as y equal to x minus 3 squared. This is the function. Okay, this is the function. You have here two options in order to solve using the genetic algorithm. You can use the command window here, or you can use the graphical user interface. Let us see if you use just the command line here. So there is a function in MATLAB called GA. So GA, the genetic algorithm. So you will open here, bracket, and then you can see here these are the options of GA. If you want to go here, this is the function name. You have to set here the function name and number of variables. And in this example, we have only one variable, x. So n vars here equal to 1. If you have equality and inequality constraints, طبعا الديفولت, let us say, in the default optimization here is the minimization problem. So default is minimization problem. And the default of the inequality constraint is less than or equal. So even if it is greater than, you can, of course, multiply by minus sign both sides to convert to less than. So this is the function, and this is the variables, number of variables. And if you have inequality constraints, if you have, for example, x must be less than or equal 10. If you have two variables here, x1 and x2, so you can write them in matrix form, coefficient of x's, and this is the absolute vector here. So A and B can be written. If you have equality constraint, you can use also equality constraint similar. You have three equality constraints in the variables. So you have here a matrix of 3 rows and whatever number of variables. It could be 2, could be 3, could be 4, whatever. So this is the number of rows here is equal to the number of equality constraints. And this is of course, the absolute vector. If you want to limit your search, this is the lower bound, and this is the upper bound of the variable. So you can limit your search to lower limit and upper limit, as we will see. Of course, you can enjoy the others later. So let us start with very simple one. Let us define, this is the function is abidu. So this is abidu, and the number of variables 1. So this is what we have here, and then okay, what is this? Create function. Oh, and I didn't save it.
Yeah.
I didn't save it. So let me save. And since this is the function, and I will need to save the file, the name of the function. So this is abidu. Okay, now we can go and do it. So as you can see here, the optimization terminated, and the average change in the fitness is 3. So this is the variable here. So this is what we expect actually. Am I right? So this is what we expect. If you, of course, as you can see here, 3.0025. Okay, or if you want to the function itself y, I think you can write here xy. And let us see. So the function value, of course, the optimal value should be 0, but this is very, very, very small طبعا, of course. The genetic algorithm approaches 3, but as you can see here, it is very close to 3. Of course, if you limit the bounds, طبعا انت الbounds here are open, or default values, which is from -10 to 10. This is the default. But if you want to limit the search, if you want to, you can get from this, the promising solution is around 3. So let us limit ourselves. Let us put some bounds, upper and lower bound here. So what we will do is, we don't have the inequality constraint. We don't have equality constraint, let us assume. We don't have any equality constraints, and we will set here the lower bound. Let us put it equal to 2, for example, and the upper bound, let us put it 4. Hopefully the solution generated here is very close to 3, closer than this one. But if you can see here, the solution here is 3.0025. When we run a genetic algorithm again, it gives us another solution, 2.99. طبعا لأن everything is random, فأنت you create another sequence of random solutions, and this is why we have. But of course, the robustness of the technique can be validated. If you calculate the average, the maximum, the minimum solution, you can see these solutions are very, very close to each other. So let us start with this. Now we narrow. We are searching in narrow range now. We limit the lower bound and the upper bound of the solution. Hopefully you can get better solution closer to 3. And this is exactly comes here equal to 3, the solution, and the function value is approximately 0. So this is the case. It's very simple, very straightforward. If, for example, you have two variables. Let us say another problem. Let us say two variables. We have here same definition. We have here x1 equal minus 3 equal to 0, and we have also another term here, which is v plus, let us say, x of 2 minus, for example, 6 square. So we have here two variables, and this is the function. Let us save it here. So what do you think the solution of the function here? What is the solution now? Minimum value. The minimum value to be 0, and this happens when x1 equal to what and x2 equal to what?
3 and 6.
3 and
3 and
6.
6. So the solution is known in advance. So let us go here and let us solve it. Generally, we have here two variables. So we can open the search, or we take the default range. There is a default, and I would like you to go over that's what we will, just in a few minutes we will discuss it. But this is for two variables problem, and let us see here. You can have the solution is 2.988 and 6.04, and this is why. So if we go back to this one and put the limits, lower limit and the upper limit. For the first variable, for x1 we have 2, and for x2 we can put the limit here equal to lower limit. Now we are talking about lower limit. What do you think?
5.
Let us put it 5. And then these are the lower bound of the x1 and x2. The upper bound, we put 4 for x1, and we put, let us put like 7 in x2. So this is the case now, and we can run GA to see this. What is this? Oh, now here two variables. You can see here number of variables. We need to adjust it. We didn't adjust the number of variables. Now we have number of variables equal to 2. Okay. So this is the solution now. You can see the solution is exactly at 3 and 6, and this is the objective function is approximately 0. So this is the way it is done in terms of the command line. Of course, you can create, a main, main program, and then you can call GA directly if you have, for example, this one. Let us say to the main here, and you can create this, and you save it as a main program. So this is, of course, needed, and then you can run the main program. So it will call the function and will solve. So again, it gives us, of course, this value is different a little bit. And the resolution of these numbers are for decimal, but if you expand it, again, it gives you for 3 and 6, and this is very, very small value. So this is the main program. You can call the function and you can run it. So this is the way. The other way to do it is to for graphical user interface, you can use the optimal tool. Optim tool, and then you can run it, and then you continue. It open like this graphical user interface. Do you see it?
Yes, Doctor.
Yes, we see it, Doctor.
So the first one here, you select the optimization technique that you need to implement. We have here genetic algorithm, so let us choose genetic algorithm, and let us define the function here. This is the function name. Number of variables is 2 in the last version. If you have equality constraints and inequality constraints, let us see for this example, specific example, without constraints, the solution is 3 and 6. Am I right?
Yes, Doctor.
Yes, Doctor.
If we add a constraint here, x1 plus x2 should be less than or equal 8. Now we know that the solution is 9, but we force x1 plus x2 to be equal or less than 8. Is it clear? So
Yes.
in that case, we can have the solution equal to 2.5
And 6.5.
and the 5.5. Am I right?
Yes.
So we can have here matrix A is coefficient of x1 and the coefficient of x2. But of course, then we have only one constraint, and B equal to like 8. So we have now x1 plus x2 less than or equal 8. So this is inequality. This is inequality constraints. Okay, so let us, of course, you can put the bounds, or let us open the bounds for the time being. But the bounds are similar to what we have in the command line. You can put it equal to a lower bound, and then the upper bound. You have 2 variables here, so you can do it as we did before. So we can start here. If we start here, let us see what is going on. After 97 iteration, we have the objective function value comes up to 0.4999 يعني 0.5. طبعا keep in your mind ان احنا we will not reach to 0 now. And with this constraints, we will not reach to 3 and 6. So this objective function, we have a certain objective function, and this is the solution. For the variable 1, we have 2.49, and for variable 2, we have 5.5 or 7. So, you know, this is the summation equal to 8 or less than 8. So this is why we reach to this solution. Of course, you can, if you have another constraints, you can also write, now A becomes a matrix. You can have it as such. I don't want to go in details, and you definitely you have good experience on this, and definitely you can go to the toolbox and see what's going on there. So this is the graphical user interface here for genetic algorithm, and as you can see, it's very straightforward, and you can see here some of the variables that you need to either you keep it as default or you specify it. And in a user default initial population, so you can have the initial population here. You cannot. In some cases, you don't need to start from scratch randomly, but you need from the last solution, for example. So you have previous solution, and you are going around this solution, so you don't need to start from scratch. You can see here population type, population size. You can specify initial range, selection function, and so on, stochastic uniform. يعني a lot of يعني here crossover fraction and elite count if you implement elite or elitism. You can have here nonlinear constraint algorithm, and there are several defaults. As we mentioned, you can play with it, or you can use the default if it is if it is okay with you. So this is the graphical user interface, and definitely I posted this global optimization toolbox in Blackboard today. So you can see here the using the genetic algorithm, you can read and you can entertain these examples here. You can have such example, and you are of course definitely for optimization we have some standard functions which is difficult functions for any technique to test against, and if the technique is able to reach to the optimal solution which is known, so you can this is the graphical interface, and of course you can go and you can see here the several examples. Defaults, crossover, mutation, and so on. So you can implement, of course, any of these options that you can use. This is also posted on the Blackboard, so you can read it and you can learn more. So if you have any question, this is just a quick tutorial. I believe these such things is you can learn it by yourself if you dedicate 1 hour to go through these examples. You can get it. Do you have any question? Yusuf. Yusuf. Yusuf Al-Hussein.
Hello.
Any question?
No, bus.
It's clear?
Yes.
Okay, great. So let us close this one. Let us close this one. Let us close also MATLAB. And then we go to this one.
Sorry, Doctor, for interruption. I have a small
Yes.
question regarding this toolbox.
Your
Is it
voice
just
is
especially sorry, Doctor. Now, is it,
okay. Yeah, it's okay. Yeah.
this toolbox is especially for genetic algorithm?
It's not for genetic algorithm. This is for different optimization techniques. You can have mixed integer linear programming. You can have if you read it here, we can go to lectures, and then we can go to MATLAB toolboxes. You have here this one. You can see here the techniques available. Of course, you can use another technique to just to compare with the genetic algorithm. You can have here. This is just a tutorial for how to. The techniques. في direct search technique, and you have a genetic algorithm. You can use also particle swarm, as we will see later on. You can have simulated annealing. Oh, it's still here also, simulated annealing. And you have multi-objective optimization. And you have different techniques here that you can implement. Okay.
Okay, thank you.
Of course, from the graphical interface, you can have several options as we show you for the drop-down menu that we have in graphical user interface at the beginning. You select one of these techniques to solve the problem. Okay. Did you still remember it?
Yes.
Tool. Okay, continue. You can hear constrained nonlinear optimization, min-max optimization, unconstrained, nonlinear, single variable, and so on. And you have different also functions here. So you will see here the other functions, simulated annealing, as you can see here, and also other constrained linear list. And there are several optimization techniques in this toolbox. So you can just use the one that you need. So for example, genetic algorithm, as we are discussing right now. Okay. Okay, so let us start a new technique.